Alright, so the next periodic trend, this is going to be electron affinity. If something has an affinity for electrons, it means it wants more electrons. It's like saying I have an affinity for chocolate. It means I want a lot of chocolate. So the question now is, what atoms want to acquire electrons? Well, to answer that question, we have to identify what atoms want to become negative charged. Does lithium want to become negative? How about fluorine? Well, lithium is a metal with a NS1 electron configuration. That's all the alkali metals have, NS1. Lithium would actually rather want to lose electrons. So lithium would have a very low electron affinity because it doesn't want to gain more, it wants to lose. So if you look at the other side of the table, we know that the halogens, they tend to perform a -1 charge. Well, that is because they have an NS2 NP5 configuration, and notice they're 1 electron short from being to look like a noble gas, so they have a very strong electron affinity. So it turns out that the halogens in group 7 of the periodic table have a very, very high electron affinity. It turns out electron affinity increases to the right, to going left to right. We know metals want to become positive, so they have very, very low electron affinity. They do not want to gain electrons. They'd rather lose them. And it turns out that electron affinity increases to going up. Now the exception with this is that the noble gases, group 8, I'm basically going to cross those off because they do not want to acquire electrons. They're already full. They have a NS2 NP6 electron configuration, so they already have full orbitals. So they do not want to acquire electrons. They do not want to lose electrons. So these have a very, very, very low electron affinity. They do not want to gain or lose. So when I talk about that going from increasing left to right, it increases to bottom up. I'm saying fluorine has the highest electron affinity, and going to the bottom here down the other way, francium would be the lowest.